Welcome to solverfy.
Here we are given a Markov chain with two states, 0 and 1, and the probability of going from state 0 to 1 is alpha, and the probability of going from state 1 to 0 is beta. For part A, we are asked to determine the steady state probabilities of states 0 and 1 in terms of alpha and beta. We can first construct our one-step transition matrix for this Markov chain. So the one-step probability of transitioning from 0 to 1 is alpha, and from 1 to 0 is beta. And the rows must sum to 1, so we know that the one-step transition probability of going from 0 to 0 must be 1 minus alpha, and from 1 to 1 must be 1 minus beta. For the steady state distribution, pi times the one-step transition matrix is equal to pi. So we can say that pi 1, pi sub 2, the product of these two matrices is equal to pi sub 1, pi sub 2. And so this gives us some linear equations. We have and the third equation that we have is that we know that the sum of pi 1 and pi 2 is equal to 1. So from equation 3, we can isolate pi sub 2. It's equal to 1 minus pi sub 1. And then if we substitute this value for pi sub 2 into equation 1, we get the following. And then collecting like terms and rearranging, we get and now if we substitute this expression of pi sub 1 into this equation, we get value for pi sub 2 in terms of alpha and beta. So these give us our steady state distribution for states 0 and 1 in terms of alpha and beta. And now for part B, we're asked what happens if alpha and or beta equals 0 or 1. So if alpha and beta are both equal to 1, then we have a transition matrix that looks like this. So if you're in state 0, you must go to state 1. And if you're in state 1, you must go to state 0. So it means that it transitions from one state to the other back and forth continuously like that, always going back and forth between the two states. If alpha and beta are both 0, then we have a matrix that looks like this. If you're in the 0 state, you will stay in the 0 state with 100% probability. And if you're in state 1, you will stay in state 1 with 100% probability, which means that the chain never changes state. If we have alpha equals 1 and beta is equal to 0, we have a transition matrix that looks like this, which means regardless of what state you start in, you're going to transition into state 1. And therefore the Markov chain will always be in state 1. And similarly, if alpha is equal to 0 and beta is equal to 1, the chain will always be in state 0. Now if we consider alpha is equal to 0 and beta is somewhere between 0 and 1, we have a one-step transition matrix that looks like this. So if we're in state 1, we may remain in state 1 with probability 1 minus beta, but we will eventually transition to state 0 with probability beta. And once we transition to state 0, we will always remain in state 0. So the chain eventually gets stuck at state 0. And likewise, if beta is equal to 0 and alpha is between 0 and 1, then the chain eventually gets stuck in state 1. And now if we consider alpha equals 1 and beta is between 0 and 1, all entries of the transition matrix in this case are positive, so it's a regular Markov chain, which means that all states are always accessible from all other states, which means that the chain may transition through states 0 and 1 indefinitely. And the steady state distribution for states 0 and 1 is given by our answer in A. And likewise, if beta is equal to 1 and alpha is between 0 and 1, this is again a regular Markov chain with a steady state distribution given by our result in part A.